So, how do you go about evaluating how good your model is? So, what are the most common metrics used to evaluate your model? So, in order to answer this question, we can start off by looking at something called the confusion matrix. So, let's just do a CM, which equals to. So we have, I think the best way for me to do this is because I remember it's true positive. True negative, I'll get to what each of these mean in a second. True positive, true negative, negative, false, positive, and then this would be um, actual, and this would be predicted, and then let's do a different color. This would be true, and then this would be false. So what this matrix essentially is telling us is that our predicted model is, so first case, so what's true positive? Oh, so true positive. True positive is essentially when our predicted model is predicting that classifying something as true, and our data is also agreeing with that, hey, it's true. And similarly here, when our prediction is classifying something as negative, which could be 0 or 1, depending on how we set up zeros and 1, our data set, our supervised data is also agreeing that, hey, it is actually negative, or yeah, so the other one basically. And so then what does false negative mean, false positive mean? So false negative essentially means falsely negative, so it means you're predicting something that's not actually negative as negative. So the actual data set says true or are positive, but you're predicting it as negative or false. So, conversely, when you're predicting something as falsely positive, it means you're predicting as falsely positive. It means that it's actually no, but then you're predicting as true. So why do we care about this, and why can't we just use something called accuracy? So the main issue with just doing accuracy is if, let's say, for example, if you have imbalanced data set. So if you have something called an imbalanced data set. An imbalanced data set would mean you have, so let's say you have two classes or multiple classes, and a subset of the classes are overexposed in the data set compared to the other ones. So, for example, if you're dealing with a lot of transactional data, financial data, it is out of 1,000 rows of data, you might have 200 rows that have fraudulent activity. So now there's a class imbalance, and because of that, accuracy does not necessarily show you the clear picture. And that is why we use something called the confusion matrix to determine a better factor in evaluating these models. So for example, so based on this confusion matrix, we have something called precision. We have precision, we have recall, and then we have the F1 score. So precision is essentially made up of all the positive guesses. So let's say these are the positive guesses. So this is a true positive guess, and this is a true positive. This is a positive guess. So among all the positive guesses, let me just double check this. Precision would be true positive. So precision is true positive over true positive plus false positive. So among all the positive classes that are predicted, how many are actually truly positive? Recall, on the other hand, is true positive over true positive plus false negative. What recall is essentially doing is checking among all that are actually true, how many are we getting it accurately correct. So this essentially can really this can basically take care of any sort of imbalance that we have, and we can check, oh, how good is the recall, how good is the precision. Now, what if we want something that's a combination of both and doesn't necessarily just focus on the positives, but can do a bit of both? That is when the F1 score comes in. We look at, and the F1 score is defined as 2 times recall times precision over recall plus precision. And oftentimes we would want to focus on the F1 score over accuracy because of the imbalance, and because sometimes due to imbalanced data set, our model may have really good accuracy but really bad false F1 score, or a really bad precision because it is not able to classify the true positives accurately, or the overall positive class accurately because of the imbalance in the data set. Cool. Thank you.